Hello and welcome. My name's Naya Murray. I'm the CEO of Tracker, and Vervium is an identity management service. I'd like to talk to you today about Zero Trust and identity as a service. I'd like to start with some information from some of the key players in the industry. So, from the Cloud Security Threat Report 2019 by Symantec, identity-related attacks are a critical threat vector in the cloud. So, identity and access management are fundamental to security. A more recent report by IBM in 2020, The Cost of a Data Breach, found that customers' personally identifiable information was the most frequently compromised type of record and the most expensive. And of course, PII data is secured by identity credentials. Now, what is Zero Trust? Well, Zero Trust started as a concept in defense, and it's quite simple, really. It's if you can't access something, you can't compromise it. So basically, it is about preventing access at the network layer. Forrester has this current definition, which is ensure that all resources are securely accessed, no matter where the network traffic is coming from. Make sure that there's a least privilege strategy for all access. That means that any end user only has access to sufficient information. And the third precept is continuously log and monitor network traffic to look for suspicious activity. And that's a very important principle. Now, let's take a look at today's security landscape. Well, it is complex. I don't think anyone would deny that. We're living at a complex time. Cloud migration is increasing. DevOps is now a primary reality. So that is a very fast turnaround of code to deployment. Infrastructure builds are increasingly automated. That's infrastructure as code. And of course, today we're experiencing a huge surge in remote working. It is complex. Whatever we're doing, security needs to be improved because in 2020, over 500 organizations experienced a data breach, and the average cost was $3.86 million US. That's a lot of money. Even more interesting is the main causes. First cause, compromised identity credentials. And the other major cause, platform vulnerabilities. So vulnerabilities in the way applications are deployed. And that covers both on-premises data centers and public and private clouds. Even more interestingly is that 80% of data breaches involve customers' personal data. And that is, of course, a great concern given data privacy regulations today. So this is the landscape. What the IBM report did find is that increased security incident response capability does dramatically reduce the cost of data breaches. However, there's something else that's happening here. And it is interesting that attack vectors, those organizations that are threat actors today, are increasingly recycling old vulnerabilities, viruses, cross-site request forgery, cross-site scripting, variations on a theme. So it appears that organizations are very slow to identify the cause of a data breach. In fact, it seems to be an escalating war of attack and defense. And this really requires a short circuit. because more and more money is being spent on monitoring endpoints and protecting endpoints and detecting breaches. However, more and more breaches are occurring, and we're not really winning this particular battle. So clearly something has to change. And what seems to be clear is that there has to be a dual focus, and the focus has to be not only protecting identity credentials, but also at the same time implementing best practice network, platform, and application security. One of the fundamentals that really does help is a reference architecture for security. So what kind of reference architecture? Well, there has to be some kind of technical foundation that approaches defense in depth. So for a start, there's application security management, and this is definitely about encouraging development and developer teams and DevOps to look at security right from the start in their coding practices. Logging and monitoring, absolutely. Everything has to be logged and monitored, including access. Deployment, in a world of CI/CD and fast turnaround times, the security of the deployment scripts is very important because a lot of breaches are occurring from inside an organisation. And that includes protecting secrets. Services, once deployed, then have to be monitored going into production. There are lots of monitoring capabilities, both from third parties and from the cloud service providers themselves, that will provide a lot of information about what's happening in real time. And those capabilities are very important. This is a design process. And all of those elements together in a written format provide an application platform technical security architecture, which can be updated as required. So what are the security principles involved in working out this technical foundation? Network segmentation is very important. At least have one anti-DDoS capability. Make sure all runtime APIs are authenticated and authorized correctly, and focus on encryption and secure key management and management of secrets. And another element is a software-defined perimeter, and that is having a network layer access control before certificate termination and before any application layer functionality is exposed to the outside world. So let's focus on identity management, since this is front, center, and key. Identity management is based on policy, who has access to what and at what level. So most all cloud service providers provide role-based access control, as do other identity service providers. And that is a suite of policies being assigned to a particular role so that access privileges can be defined across a service. And then users and groups of users can be assigned roles so that those policy permissions don't have to be defined over and over again. And as well as role-based access control, attribute-based access control is becoming increasingly important. Now, for end users, and particularly person end users, multi-factor authentication is now pretty well essential. So that is simply having multiple factors to ensure that authentication is correct. Another important consideration, of course, is privileged identity management, particularly in a world of DevOps, where the turnaround time is quick, the business imperative is fast, and developers are not security experts. So with all the best will in the world, trying to turn a DevOps team into a secure DevOps team is probably not your first line of defense for security. So making sure that there is strong privileged access controls in place so that whoever accesses code is monitored, and that is for inadvertent breaches as well as for hostile breaches by an insider. So fine-grained access control is very important, and of course credentials and strong credentials are very important to secure the internal environment. All of policy can be monitored, so the cloud service providers do provide default logging and monitoring services out of the box, and they can be configured, and third-party monitoring capabilities all can be aggregated to report and provide dashboards on access control. However, from the experience of IBM's data breach report, it's pretty clear that there's something wrong with the way we're using identity credentials. So I'd like to propose that we need a new best practice. So way back in the dark ages, user ID and password were considered to be strong enough to secure most resources. It does seem like a lifetime ago. However, there are organisations who still use user ID and password in clear text. So why do we still have vulnerabilities? Well, there are basic vulnerabilities in all of the network layer protocols. I can only guess that the reason for this is that most of these protocols were defined well and truly before we had security problems as big as the ones that we have today, where identity fraud is the major vehicle for crime. And as well as that, there are basic flaws in every authentication mechanism. Any type of token, SAML, OAuth 2, DOT, JSON Web Tokens, biometrics, even if there is multi-factor authentication. It's well known that there's cross-site request forgery and cross-site scripting attacks, man-in-the-middle attacks, browser flaws in the caches that have been exploited by hacking organisations. So one improvement that organisations have started to make is to encrypt at the field level, because TLS, that is HTTPS, even the latest version, have flaws, and certificates have flaws. They can be badly deployed, they can be out of date, or there are plain vulnerabilities that hacking organisations know very well how to exploit. So encryption at the field level is important, but if you're going to use PKI, a key pair, make sure that you use the right key size, minimum 2048-bit these days. For symmetric encryption, that is an ephemeral key that's used as a shared secret, make sure that you use a minimum strength, and for AES that's a block size of 256. And for any hashing algorithms, make sure that you don't use SHA-1, which has been deprecated, but SHA-2 or SHA-256. So what is clear is that no matter what we do to improve the credentials, it seems that there's a very clear pattern that anywhere you have a complex handshake at connection, so that includes TCP itself, a handshake that is multi-step, or an OAuth 2 dance, which is a protocol that was developed for developers to use an external authentication mechanism like Google, it has multiple steps. It seems that hackers are creatively finding new ways to exploit these multi-step processes, either at the network layer or at the application layer. So avoid complex handshakes is probably a clear conclusion. really, identity management and zero trust network connectivity have to be designed to go hand in hand. So, for example, you might use encryption in a browser to send credentials across the public internet for a home worker, and that's fine. They can be authenticated at an authentication gateway for a cloud or for an enterprise network. However, this really has to be allied with a network layer protocol that will allow or deny based on the authentication mechanism, so that access to a network is denied until identity is proved. So that is the emerging new best practice. So what is software-defined perimeter exactly? Well, let's take a look. It's actually a specification that's been produced under the auspices of the Cloud Security Alliance by the SDP Working Group. And while there are lots of different types of SDP deployment, basically the whole idea is to authenticate at the network layer prior to allowing any access. So this means separating the authentication flow from the access flow. And as you can see from the diagram, authentication happens outside of a software-defined perimeter, which is the protected enterprise resources and corporate data assets. This has a number of advantages. Only allowing application level access means that network escaping inside an organisation where a lot of damage has been done in the past isn't possible. So this means that with a good SDP deployment, an end user can only access what they're intended to see. And this is the same for devices or applications or people. Any type of protocol can be applied, so it can be across the public internet, it could be an RDP, a remote desktop access, it could be an IoT device using any type of connection protocol. So this also has a secondary function of reducing malware propagation, as well as ensuring identity credentials are protected. So it really is a winning combination. Authentication, particularly with encrypted data coming from across the network without exposing any identity credentials. Authentication happening at a gateway, and only once authentication, and that can be multi-factor authentication, is ensured, does the gateway open to allow access into the network. In fact, it's a newly emerging paradigm, a paradigm shift over the next few years. So underneath software-defined perimeter, you have to have a secure network. We'll just briefly take a look at what is secure networking, that networks and subnetworks are isolated for particular reasons. Look at data privacy, look at access, look at what you don't want ever accessed by another subnet. Use network security groups properly, make sure all of the port inputs and outputs are correctly defined for a particular service. Make sure that when you have site-to-site network connectivity, which many organisations do these days, not only from internal domain to internal domain, but from cloud to cloud and to third-party providers. So on a case-by-case basis, design the network connectivity for security. That means making sure that highly classified data is definitely encrypted. And also test extensively. Make sure that enough time is left for testing inbound and outbound flows at every level, for applications, for data, for network connections, for all sorts of storage. So another important capability to ensure that platforms are secure is to make sure that they stay available. That might seem pretty obvious, but really you have to make sure that the sizing and capacity for the VMs is sufficient for not only primary loads but all of the burst loads. Make sure that the platforms are highly available, and that given that cloud service provider services are now very numerous and very complex, on a service by service basis, make sure that you've got a primary and an automatic failover when you have an application that requires 24/7. Databases, same thing. You must prepare in case of a failure for a secondary instance online, and make sure that your environments are sized correctly for infrastructure, for platforms, and particularly, take note, your production environments is your face to the world. So storage, very important to have encrypted storage. There is no knowing when there will be some kind of complete failure, and certainly nobody wants to be caught with clear data, breaking data privileges and data regulation compliance. So make sure all of the storage and backup is appropriately encrypted. Back to logging and monitoring, which is the key underlying zero trust capability. Look at all of the minimum control standards that are required. Now, I know that there are so many these days that you practically need a PhD in control standards to understand how to comply with all the legislation and regulation. But you can become selective. You don't have to apply everything for every application. So this can be part of the architecture, working out what are your minimum control standards for a particular deployment. By the same token, make sure you retain data for as long as it's needed, and there are legislative requirements there. Make sure that encryption is appropriate. Make sure that you collect host metrics, infrastructure metrics, performance metrics, because in fact, performance metrics are one of the key indicators of a security breach. So if you want your incident response people to alert on a positive basis, make sure that you have logging dashboards that will allow people to look at both infrastructure metrics and security metrics to avoid some of the deluge of false positives that are coming from some of the security platforms. The more information that you have logged and monitored, the better your security posture is going to be. And of course, access to endpoints monitoring is critical. So you have event history, you have analytics of events. By aggregating the logs, you can apply machine learning and security analytics, a field which is advancing rapidly. So now there's some really brilliant endpoint AI. I think they're calling it today SOAR, Security Orchestration Automated Response. And of course, some of the basic logging and monitoring is free. It comes with cloud service providers, and make sure that, that they're taken advantage of, and that you use log aggregation to ensure that you get a complete picture. So that'll give you identity management, role-based logs, web application firewalls, certificates, key vault logging, gateway logging, application and database logging. It's all part of a very comprehensive picture, and the new challenge is to learn to read all of the data. Okay, and finally, we have to take one short look at disaster recovery, because in fact, I think we've all learned something from the world of global pandemics, and that is always expect the unexpected. Part of your architecture, part of your security architecture, is having a section on disaster recovery and making sure that, okay, if you can get away with just having an availability region failover, and that's not going to affect your business, fine. But if you have to, go for full active or passive DR configuration because of the essential nature of what you've got online facing your customers, then make that decision based on what will really work. And another factor that has to go into that mix, a global pandemic is not going to snap back to the old way of working in a hurry. So remote working from home is a new reality for many, many organisations, and we do need to take into account that that is part of the security planning for disaster recovery. I found this Dilbert cartoon from 2009. It's quite humorous, and I included it basically because it was from 2009, and it is about all of the things we've all become very familiar with, which is don't shake hands, don't breathe on anyone. And this is just a joke about how not to keep your customer. But it does provoke thought about how are we going to get and keep customers in a world that is now quite different from the one that we knew 6 months ago. So the key takeaways: identity management is not working as well as it should, and that we are inadvertently putting a lot of flaws, security flaws, into our deployments at the application layer. So in order to have a cost-effective, cost-efficient way of addressing security going forward, it really is important to look at having zero trust and identity management as a key part of the security strategy. I hope you enjoyed the presentation, and feel free to get in contact if you've got any queries. Thanks for listening.